So here's our current structure. We have this HTML node interface with two methods, highlight and plain text. We have concrete implementations of this interface, such as heading node and anchor node. And we have this HTML document that maintains a list of HTML nodes. Okay. Now, as I told you in the last video, this violates the open-close principle because every time we want to support a new operation, we have to change all the types in this structure. So that is one problem. The other problem is that the logic for each operation is spread over different classes. For example, think of the highlight operation. A part of our highlighting algorithm will be in the heading node class, another part will be in the anchor node class, and other node types. So the logic for each operation is not in a single place, it's spread over different classes. To solve these problems, we need to represent each operation using an interface. So we can introduce a new interface called operation with two methods. Apply, that takes a heading object, and apply, that takes an anchor object. This is what we call method overloading. That means a method can have the same name, but it can have different signatures. So it can take different types of parameters. Now, you might be wondering why we need method overloading here. Well, we'll talk about that in a second. So if we represent each operation using an interface, then we can create concrete operations such as highlight operation and plain text operation. With this structure, all the logic for a given operation will be in a single place. Because in our highlight operation class, we're going to have two apply methods, so we will have the logic for highlighting a heading as well as highlighting an anchor object. So all the logic for this operation will be in a single place, okay? The other benefit of this structure is that it follows the open-closed principle. So if tomorrow we want to support a new operation, we simply create a new class that implements the operation interface. So these are the benefits of this solution. However, we should use this solution only if our object structure is stable. So currently we have two types of nodes here, heading node and anchor node. That is the reason why in our operation interface, we have two apply methods, one that takes a heading object, the other that takes an anchor object. If our object structure is not stable and we're going to end up with new types quite often, then every time we introduce a new type, we have to modify the operation interface as well as all the classes that implement this interface. So once again, we should use this approach if our object structure is stable, but we want to support new operations frequently. An HTML document is a great example because in HTML, we don't have unlimited types of nodes. We have about 20 to 30 types of nodes, but quite often we need to support new types of operations. For example, tomorrow we will want to add a new operation to extract the images or the links in an HTML document. So we don't know what operations we need ahead of time, but we're fairly certain about our object structure, okay? Now let's see how we can bring this operation interface into our current structure. So here's our current structure. We have this HTML node interface with two methods, highlight and plain text. And here are the classes that implement this interface. Now, we want to get rid of these specific methods. We want to replace them with a general purpose method like execute. This method takes an operation object. So here we have a dependency relationship to our operation interface because the execute method takes an operation object. Now, we should implement this method in each concrete node type. Now, what do you think we're going to have in these concrete implementations? It's very simple. Let's talk about this execute method. Here we take an operation object, and this operation object has two methods. The apply method that takes a heading object and the apply method that takes an anchor object. So in this method, we call operation.apply and pass this as the reference to the current object. Because we are inside the heading node class, this will represent a heading node object. So this line will cause the first apply method to be called. Similarly, in the anchor node class, we're going to implement the execute method, and our implementation is going to look exactly like the implementation of the execute method in the heading node class. We call operation.apply and pass this. Because we are inside the anchor node class, this represents an anchor node object. So this line, this statement will call the second apply method of this operation object. And this is what we call the visitor pattern. Now, where does the name come from? Nowhere we talked about the concept of a visitor. Well, here's the structure of this pattern in the Django 4 book. So instead of the operational interface, we have the visitor interface. This is a general purpose name they came up with. So we have this element, which is like our HTML node interface, that accepts a visitor. This is like the execute method that we just talked about. In each concrete element implementation, we're going to take this visitor, call its visit method, and pass this as the reference to the current object. Once again, these are just some abstract names. Don't worry if they're confusing. What matters is that the visitor pattern allows us to add new operations to an object structure without modifying it. Every time we want to support a new operation in this structure, we simply create a new class that implements the operational interface. As simple as that. We're going to look at implementing this in the next video.